Reference table K, we find the common acids. And amongst the common acids, we see hydrochloric acid, and we notice that it has both hydrogen and chlorine. But when we look at all the other acids, we see that they have hydrogen in common. Therefore, hydrogen is the best choice. The next question asks what could be a reactant in a neutralization reaction. Remember that neutralization reactions are when an acid and a base combine to form salt and water. So here we are looking for either the formula of an acid or the formula of a base. Using reference table K and L, we'll note that the formula of a base, potassium hydroxide, is provided. So the best answer is potassium hydroxide. The next question describes a titration. In this titration, we are beginning with nitric acid, and we are adding a known volume of sodium hydroxide. The question asks, what color change will the phenolphthalein undergo? Well, since we start with an acid, which has a pH of below 7, then we end up adding a base, which has a pH above 7, what we're going to observe is that the phenolphthalein will change from colorless to pink. This is shown on reference table M. The next question asks you to show the correct numerical setup for the titration. Again, we'll use our reference table, this time table T. Notice the question asks for the correct numerical setup. Therefore, there is no need to solve. Question 6 refers to the Arrhenius theory of bases. Now we can again look at reference table L for some hints. Looking at reference table L, the thing we'll notice that they all have in common is they all end in OH. Now, hydroxide is the only negative ion in solution according to the Arrhenius theory. In question 7, we have a titration. Again, we're going to refer to the titration equation on reference table T. In the next question, they're asking about the hydronium ion concentration. If you are not sure what hydronium is, let's refer to reference table E. As you can see here, hydronium ion concentration is the same thing as the hydrogen ion concentration. If you were unsure that hydronium ion was a polyatomic ion, you could also check reference table S, where it is not listed. Therefore, you would have to look at table E. Now, using our illustration of pH, using the square box, we realize that we're starting at a pH of 5, and we are moving on to a 100-fold decrease in hydronium ion. Hydronium ion is the same as hydrogen ion. So if I'm decreasing my hydrogen ion, we're moving in this direction. So a 100-fold decrease is going to be a 10 to the power of 2 difference. So that means from 5, I'm going to change 2. So that's 5, 6, 7. So 7 would be the new pH. The next question has us referring to reference table F. So we are looking for a soluble hydroxide. So we're going to examine right here. So here in the common bases section, you'll notice that bases tend to end in hydroxide ions. And if you're unsure of the charge of hydroxide ions, you can look at reference table E or F. Here, reference table F, since it's already up, we can see hydroxide is negative. So our best choice is going to be choice 3. In this question, we are looking for an electrolyte. And as we recall, electrolytes include acids, bases, and salts. So we can again refer to reference table K and L to determine if we can locate an acid, base, or salt. Here you'll notice that we will find the formula for acetic acid. So acetic acid is an electrolyte. In the next question, we're looking for neutralization. Recall that neutralization is when we combine an acid and a base to form salt and water. Neutralizations require water as a product, so the only reaction where water is a product is the fourth reaction. Notice we have water here. Now we can also use reference tables K and L to help us locate the acid and the base. So here you can see sulfuric acid is located on reference table K. Now magnesium hydroxide is not on reference table L, though other hydroxides are. As we continue, here we are going and looking at areneous acids, and we can recall that in areneous acids, hydrogen ions are the only positive ion in solution. Again, when we look over at our reference table K, we can see the acids all contain hydrogen, but they also contain other ions. Our reference table can help us determine that the other ions are negative. In this next question, we're looking for the substance that will represent sodium hydroxide. Now, again, referring to our reference table K and L, you'll notice that sodium hydroxide is here, and it is a base. Now, when we look at the chart, the first criterion which we're going to help identify sodium hydroxide is conductivity. And we recall that conductivity refers to electrolytes, and the three electrolytes are acids, bases, and salts. So sodium hydroxide, because it is a base, will be an electrolyte, or a good conductor of electricity in solution. So that means we can eliminate two of the choices. Next, we're going to evaluate the color in phenolphthalein. So, since sodium hydroxide is a base, and we imagine our number line or our pH scale, remember that bases have pHs greater than 7. So when we look here at reference table N,